everyone, welcome to Prakriya Educations. I am Mallikarjuna. Today we shall discuss about a very important topic of class 12 mathematics, relations and functions. Before entering directly to the class 12 topics of relations and functions, I prefer to give an introduction about the concepts that you have already learned in your class 11. And hence, in this video, we shall have an introduction to relations.
In this module, we shall learn about the ordered pairs, the Cartesian product of any two given sets, and also the basic concept of relations.
Socially, we come across many kinds of relations like mother and daughter, father and son, teacher and student, and many more. Likewise, can you guess any relations in mathematics? Look at these examples. When you are concentrating about arithmetic, take any two numbers. For example, if I am taking 5 and 2, you can relate these two numbers as 5 is greater than 2. Again, if I am taking 7 and 10, you can tell 7 is less than 10. These are some of the relations that you come across in arithmetic. Now, if you concentrate on the algebraic terms, taking any two variables, you can relate the variables as A is less than or equal to B, X is greater than Y, or sometimes P is equal to Q, so on. If you are considering any two sets, you can tell that if A and B are any two sets, then you can relate A and B as A is a subset of B or X is a subset of Y, and many more. If you are looking geometrically, then if I consider any two lines L1 and L2, and if I tell L1 line is parallel to L2 line, then there is a relation between these two lines, that is L1 is parallel to L2. Another two lines like L3 and L4, if I am telling L3 and L4 are perpendicular to each other, then again another relation exists. Likewise, you can come across many such relations in mathematics. Now, in depth, we shall learn about the relations which occur when you are having any two sets. Also, remember that the concept of relations and functions is very important for the further topics like inverse trigonometric functions, differentiation, integrations, and so on. The first topic that you have to be very much clear with before entering to the topic of relations and functions is about the ordered pairs. Two elements written in a specific order is nothing but an ordered pair, and we denote ordered pair like this, where A is the first element of the ordered pair and B is the second element of the ordered pair. Now, we shall have a Cartesian plane which helps us to understand about the ordered pairs very clearly. Now, I wish to mark a point on this Cartesian plane. Okay, let us consider a point 2, 3. To mark this point, you have to just draw a perpendicular line to the x-axis at the intersecting at the point 2 and draw a perpendicular line to the y-axis intersecting at the point 3. Fine. Now, the intersection of these two perpendicular lines gives us the point on the x-axis 2 and on the y-axis 3. Fine. Where 2 is the x coordinate and 3 is the y coordinate. Now, if I wish to mark the same point in the reverse way, that is, if I wish to mark 3, 2, where is 3? Now, the point 3 here and the point 2 on the y-axis, the perpendicular lines which intersects these two are nothing but this one, and hence you get the point 3, 2, where 3 is now the x coordinate and 2 is now the y coordinate. You can clearly observe that the point 2, 3, and 3, 2 are in the different positions, and hence you can tell this is x1, y1, a different point, and this is x2, y2, a very different point again. And hence you can observe that for any ordered pair, if you are reversing the elements which are in the ordered pair, then you get a different ordered pair. You cannot tell the two ordered pairs when it is reversed. That is, if you are having A, B as one ordered pair and B, A as another ordered pair, these two ordered pairs are never equal to each other until and unless A is equal to B. You can note that if A is equal to B, then you can tell that AB is equal to BA, and in all the other cases, AB will never be equal to BA. Always remember, the order is very important. You may be confused with the concept of sets, that in the sets, if you are having a set A, B and the set B, A, always these two sets will be equal to each other. This is the major difference between a set and an ordered pair. In set, there is no importance for the order. You can rearrange the elements as you wish, whereas in the ordered pairs, always this order is very important. The next concept is about the Cartesian product of any two sets. Consider two non-empty sets A and B. Then the set of all ordered pairs A, B such that the first element A belongs to the first set A and the second element B belongs to the second set B. Then this is called as the Cartesian product of these two sets A and B. Let us have a small example. Consider two sets A as 1, 2, 3 and a set B as A, B. Then the Cartesian product of these two non-empty sets A and B usually denoted as A cross B. Then A cross B will be equal to, take the first set, that is A, 1, 2, 3 cross the second set A, B. Take the arrow diagram. Firstly, to understand about the Cartesian product, the set A has 3 elements and the set B has 2 elements. Now go on connecting every element of A to every element of B. Now 1 will be connected to A. Again 1 will be connected to B. Hence you have got two ordered pairs now, 1 and A. That is the first ordered pair, 1, A. The second one, 1, B. In the similar way, go on connecting every element of A and hence you get another 4 ordered pairs, 2, A, 2, B, 3, A and 3, B. This is called as the Cartesian product of the two non-empty sets A and B. Now, if I am taking the reverse order, that is B cross A, try to find the Cartesian product. The set B is A, B cross the set A, 1, 2, 3. Try it without the arrow diagram. Start with the first element of B. Go on connecting the first element to every element of the second set, that is A. Hence you get the ordered pairs as A, 1, the first one. The second connection A, 2. The third A, 3. In the similar way, go on connecting the second element B also. This is the set of all ordered pairs and which gives the Cartesian product of two sets B and A. Usually you may guess that 1, A and A, 1, those two elements are present in the both Cartesian product, and you are usually making a mistake that A cross B will be equal to B cross A. But that is a major mistake, because we had already learned in the ordered pairs that A, B is never equal to B, A until and unless that A is equal to B. And hence you can generally tell that A cross B is never equal to B cross A until and unless A and B are equal sets. Now we shall try to find the Cartesian product of A cross A. Consider the same set twice. A is nothing but 1, 2, 3 cross the same set 1, 2, 3. Now go on connecting every element of A to every element of the second set A itself. Then you get the Cartesian product as 1, 1 the first connection, 1, 2 the second one, 1, 3 the third one. Go on connecting the same way. This is the Cartesian product from the set A to the set A itself. Now try the same for B cross B also. Hence we get. Now again consider another example. If I am having two sets A as 1, 2, 3 and a set B as a null set, a set which contains no elements, then now try to find the Cartesian product of these two sets. That is, we shall now try this with the arrow diagram. A contains 3 elements and B contains no element. Now, is there any option to connect an element of A to an element of B? You cannot connect any element of A to the set B because B contains no elements, and hence the Cartesian product of A and B will be again a null set. And hence you can conclude that if any one set is a null set, then the Cartesian product of those two sets will be always a null set itself. Recall another formula that if the number of elements of A is equal to P and the number of elements of B is equal to Q, then the number of elements in the Cartesian product of A cross B will be equal to the number of elements of A into the number of elements of B, and hence N of A cross B will be nothing but P into Q. You can verify with this example actually. Now the first one, you can take this as the first and this as the second one. For the first one, the number of elements in A is nothing but you are having 3 elements and the number of elements in B is equal to 2. Now the number of elements in the Cartesian product will be equal to 3 into 2 according to the formula, and hence 6. Now go on checking in the Cartesian product, you can find 6 elements. Now in the similar fashion, check for the second example also. N of A in this example is again 3 and N of B is equal to 0. No elements, and hence the number of elements in the Cartesian product is equal to 3 into 0, which gives back us 0 itself. Coming to the main topic of the module, relation. Let A and B be two non-empty sets. Then the relation R from the set A to the set B is always a subset of the Cartesian product A cross B. And hence you can tell R is always a subset of A cross B. Now, if you are having the relation R from the set A to the set B, and if an ordered pair A, B belongs to the relation R, then you can tell that the element A is related to the element B and denote it as A is related to B. If the ordered pair A, B does not belong to the relation R, then you may tell that the element A is not related to the element B and denote it as A not related to the element B. Consider an example. I have taken two sets A and B and also found the Cartesian product of those two sets. Now, if I am writing a relation, now relation is nothing but I am giving a condition for the ordered pairs. I am telling that each element of the ordered pairs should satisfy this equation A is equal to B, where always the first element A belongs to the set A and the second element B should belong to the set B. Now go on checking in the set of the Cartesian product which satisfies this equation. Now A should be equal to B. The first element should be equal to the second element. Now checking this, you get 1, 1, 3, 3, 5, 5. These three elements satisfies the equation A is equal to B, and hence the roster form of the relation will be 1, 1, 3, 3, 5, 5. You can observe that the relation R is a subset of A cross B. Take another relation. If I am telling R is equal to A, B such that A plus B should get me 25, where A belongs to A and B belongs to the set B. Now, if you are going on checking with the elements, you can see that none of these ordered pairs satisfies the given equation A plus B is equal to 25, and hence the relation does not contain any ordered pairs, and hence this is a null relation or an empty relation. You can again clearly tell that R is a subset of A cross B. Also remember that if n of A contains P elements and n of B contains Q elements, we already know that the number of elements in the Cartesian product will be P into Q, and from this you can tell that the total number of relations from set A to set B is equal to 2 to the power of P into Q. Now we shall learn about a few concepts which are related to the concept of relations. The first one is the domain of the given relation. The domain of the relation is nothing but the set of all first elements of the relation R, which is defined from the non-empty set A to the non-empty set B. Look at this example now. You can check that the first elements of this relation are 1, 3, 5. Look at the arrow diagram which helps us. I am having two sets A and B, where A contains 5 elements and B contains 3 elements. According to the relation R which I have defined here, go on connecting the elements which are connected, that is 1, 1, 3, 3, 5, 5. You can check that there are 5 elements in the set A, and out of 5 elements only 3 elements are related to the set B and are present in the relation R, and hence the elements which are connected from the set A to set B are called as the domain of the relation R and is denoted by D of the relation R, which is the set of 1, 3, 5. Also remember that the domain of every relation R will be the subset of the first set A. Now the second concept is about the range of the relation. The range of the relation is nothing but the set of all second elements of the relation R. Look at the arrow diagram again. The second elements which are connected from the first elements are 1, 3 and 5, and hence the range of the relation R is nothing but 1, 3, 5. Also remember that the range of the relation R will be always the subset of the second set, that is B. The next concept is the inverse of a relation. If A and B are again two non-empty sets and R is the relation defined from the set A to the set B, then consider R is equal to the set of all ordered pairs A, B such that A belongs to the first set A and B belongs to the second set B. Then R inverse, denoted like this, is equal to the set of all elements B, A such that the reverse one, that is A, B, will be in the relation R. Look at an example. And I have defined the relation as, then the inverse of this relation will be nothing but, go on reversing the ordered pairs. If you have 1, A, then the inverse of the relation contains A, 1. Then this when reversed you get A, 2. This when reversed you get B, 3. This is nothing but the inverse of a relation R. And hence clearly, if an ordered pair A, B belongs to the relation R, then B, A will be an element in the relation R inverse. And also observe that in the relation R, if I am writing the domain of the relation R, the set of all the first elements, that is 1, 2 and 3. 1, 2, 3. This is the set of all first elements of the relation R. Similarly, writing the range of the same relation, you get A, B. And now try to write the domains and range for the R inverse. Domain of R inverse is equal to the first elements A. Since it's repeated, you can write it once, then B. Then the range of the relation R inverse, 1, 2, 3. You can clearly notice that the domain of R will be the range of R inverse and the range of R will be the domain of R inverse. And hence you can tell that the domain of the relation R will be equal to the range of the relation R inverse, and similarly the range of the relation R will be equal to the domain of the relation R inverse. That's all for the day. In the next module, we shall learn more concepts about relations that we come across in class 12 mathematics. Until then, enjoy doing math. Please don't forget to like, share and subscribe the channel. Thank you.